The whole point of algebra is to be able to figure out things in the real world in the most easy way possible. So, in order to do that, we have to be able to convert real-world situations that we normally would use words to describe into simple algebraic expressions and equations so that we can solve and figure them out. So we're going to look at a few examples here, and I'll give you some pointers and some helpful hints. But this is one of those things that you just have to kind of figure out a logical way. What is the sentence saying, and what's a logical way to write it? So let's look at the first one. 8 times, and right here, this is the first thing, 8 times a quantity. So a quantity generally means that you're going to put something into parentheses. So 8 times the quantity, and something's going to go in there. And you want to, they're usually set up, these kinds of sentences are usually set up when we speak in the form of telling you what you're going to do and then giving you a this and that, which is in front of and behind what you're going to do. So let me show you what I mean. Times means multiplication. So you find this word times and you think, okay, I'm going to multiply two things together. What are they? Well, there's the this, which goes in front, and the that, which is going to be the quantity, all of this part. Okay, so once you get the this and that, now you have a second setup, right? Well, the quantity we know is going to have a multiplication, so what is in the quantity? 4 plus a number n. Well, plus is a plus sign, so you put that down, and then you go for this and that. Well, what's the thing in front? 4. And what's the thing after n? I know, the first time you hear it, it doesn't sound very simple to put together, but it actually is something, you'll find with repetition that it'll make total sense to you. So let's look at another one. 12 decreased by a number x. Well, decreased by a number x, decrease means minus. And this is going to be a this and that because you have the decreased, and this would be 12 and that would be the number x. So you're saying 12, take away from 12 some x value that you don't know what it is yet. All right, let's look at another one. 3 times 8 and a number. Well, again, we have times, this and that. Oh, 3 times 8 and a number. Okay, so the this is clear, that's 3. But 8 and a number, it's not just 3 times 8, right? It's 3 times 8 and a number. So this side is going to be 8, or excuse me, let me use the this and that method. And always means plus, so it's a plus. This goes on the front, that goes on the back. Okay, so that kind of makes a little bit of sense. You and 4 friends meet to have dinner at a restaurant. Everyone decides to order the nightly special. Write an expression for the total cost of the meals. Okay, so let's see the information that's important. Well, you and 4 friends. So 5 people. I'm not actually even thinking yet about what the question is asking me to write. I'm just thinking, what is all the information that might be value? Meet to have dinner at a restaurant. Everyone decides to order the nightly special. Write an expression for the total cost of the meals. So everyone ordered exactly the same thing, right? And the nightly special, we don't know what the price of the nightly special is. It's an unknown value. So we need a variable for that. So let's let x equal the nightly special. So, well, write an expression for the total cost of the meals. Well, that would be 5 people times the cost of the nightly special. That was actually easier than I thought. All right, so I paused and it just popped right a new problem up. So the length of a building is 20 feet more than its width, W. Write an expression for the length of the building. So this is one of those things where we know that the length of the building, I'm just going to sketch in sort of the footprint of the building, and then I'll dot up. So this would be the walls of the building. But what we care about is the length and the width of the building. So if I identify this is the length and this is the width, Well, I know that the length of the building is 20 feet more than its width. So the length could be written as the width plus 20 feet. Now the problem is, I don't know the width of the building, so I can't actually tell you what the length of the building is. But I can say that whatever the width is, if you would tell me the width, I'd be able to tell you the length because I could just add 20 to it. So the expression we want to use is that the length of the building equals W plus 20 feet. Okay, so you're going to have to just practice those. You'll get better with time, and use your common sense when you put it together, and use the this and that idea, and you got to go with that. But there's another concept which we want to talk about, and that is the unit rate. Unit rate. So a good example of the unit rate would be you buy a dozen eggs. You buy a dozen eggs for $4. Right? So that makes sense. But we want to know the unit. We want to know what one egg costs. What's the cost of one egg? So the first thing you want to decide is a conversion factor. A conversion factor is something that has different units, so the values might seem different, but they actually are equal to each other. And in this case, the things that are equal is that 12 eggs, 1 dozen, right? 12 eggs equals $4. So these are dollars and these are eggs, but these are equal to each other because that's how much money you had to spend for the 12 eggs if you purchased them. So in order to set up a unit rate, we want to know what is the cost of one egg, right? So that means that we're looking at it cost $4, and we're putting cost in the numerator because that's the thing we want to know, right? It costs $4 for 12 eggs. Right, so we can set up a ratio with these two values since they equal the same thing. This is really like a number 1 because if I had the number 2 over 2, we know that that equals 1 because 2 is exactly the same thing as 2, so that equals 1. X over X also equals 1 as long as X doesn't equal 0 because you can't have a 0 in the denominator. Or let's see, 16 over 4 squared equals 1 because 16 and 4 squared have the same value. And so these equal 1. So what you've really done is set up a conversion or a ratio for converting. So here's what we want to do. We know that it costs $4 for 12 eggs. We want to know what does it cost for one egg. So you have to ask yourself, in order to turn 12 eggs into one egg, I would have to divide, sorry, let me not do that yet. I would have to divide the denominator by 12 because 12 divided by 12 equals 1, which is always allowed as long as I also divide the numerator by 12. So what happens if I do? Well, 12 divided by 12 is just going to equal 1. So I get 1 in the denominator, 1 egg. And in the numerator, I get 4 divided by 12. So that's a fraction, 4 divided by 12. First thing we want to do is look at reducing it. So we know that reducing this would be a matter of finding the product of primes for it. And then 2 times 2 times 3. And canceling what you can, and you end up with the numerator having 1/3 divided by 1. So you know 1 egg. So that's a little unwieldy. That says that 1 egg costs 1/3 of $1, right? Because we started with dollars. So 1/3 of $1. Okay, normally in algebra, we want the fraction. We don't want to convert this to a decimal. But this is a real world situation. Sometimes you'll say a half a dollar, but people don't generally say I spent a third of a dollar on something. What they say is they spent so many cents. So we want to go ahead and convert this to cents by just doing 1, and I'm sure you already know the value, but 1/3 equals. So that's 33.33333 cents. So what we spent for one egg was approximately 33 cents for one egg. Or, said in unit language, 33 cents per egg.